Hello again, everyone. Welcome to another session of Additional Mathematics. For this session, we will be continuing our view of coordinate geometry. I am Mr. Salmon and will be your facilitator for this session. Let us look at the objectives that will be covered for today. We will determine whether lines are parallel or mutually perpendicular using the gradients. We will also find the point of intersection of two lines. But just before we go into these objectives, let us review an example. Find the equation of a line with graph. So now we have the graph, and we have 2 points on this graph. And we are asked to find the equation of this line. How do we go about that? Now you should be remembering some concepts that were covered from the last session. So let us now go together and find the solution for this question. Since our 2 points are 2, 4, and 6, -1, let us now go and find the gradient of this line. How do we find the gradient of a line? Remember that it is the vertical change written as a fraction of your horizontal change. Therefore, your vertical change is written as -1 minus 4, while your horizontal change is 6 minus 2. When you have simplified that, you will get -5 of 4. And that is now your gradient. Since we now have the gradient, we can choose to use the gradient point form. Remember that from the gradient point form, you can use any of the point along with the gradient. And in this case, we choose to use the point 4, 2, 4. Therefore, we now have the equation y minus 4 into -5 of 4 into x minus 2. Let's go again. Our equation is y minus 4 is equal to -5 of 4 into x minus 2. After you have done this, you can now rearrange your equation so that you have the correct equation form that you are looking at. By the way, in some instances, you are allowed to leave your equation in this form if the question did not say you must simplify. When we rearrange, we end up with 4 into y minus 4 is equal to -5 into x minus 2. And further simplifying give us 4y minus 16 is equal to -5x plus 10. After simplifying that, you will get 5x plus 4y is equal to 26. And right here, you have your equation. And as you can see, this equation was written in the general form. Let us now review 2 basic concepts that we had done from CSEC level and that you should know and you should remember to properly master this course. Now, number 1, they are gradient of parallel lines. Keep in mind that if 2 lines are parallel, then they have the same gradient. While if two lines are perpendicular, we know that their gradients are negative reciprocal of each other. So we know that if one line is m, then the other line will be negative 1 of m, which is the negative reciprocal. And to prove this point, the product of both lines' gradient should be equal to negative 1. Let us now look at some examples. So the second example that we will go through in this session is find the equation of the perpendicular bisector of the line segment PQ, where P is 4, 2, and Q is 8, negative 6. How do you go about finding the equation of this line? Please note that you have 2 points. Since you have 2 points, then you can go about finding the gradient of these 2 points. And the gradient after calculation is negative 2. Keep in mind that your gradient is your rise over your run. And since we know that the gradient of PQ is negative 2, and as we had reviewed just now, that the gradient of a perpendicular line is the negative reciprocal of the other, then we know that the gradient of the perpendicular bisector is 1/2. So since we know that this is the gradient of the perpendicular bisector, then we can go about finding more information that will help us to find the equation of this line. Now, our question said perpendicular bisector. What is a perpendicular bisector? I know you are saying it, and you are correct. The perpendicular bisector is the perpendicular line that cuts the other in 2 halves. So in this case, we realize that we should find the midpoint of the line PQ. So there you have it. We had gone ahead and find the midpoint. Now, I would like you to pause the video right here, go ahead for yourself and find the midpoint of the line. And ensure that you get 6, negative 2. After you have found the midpoint, we can now see what else we need to have. So far, we have the midpoint, and also we have the gradient of this perpendicular bisector. In other words, we have 1 point and the gradient. Therefore, we can use the gradient point form and find our equation. And after we have done that, we should get y plus 2 is equal to half into x minus 6. Remember, y minus a negative 2 is the same result as having y plus 2. Now, your equation could be left as that, as was said before. However, let us go ahead and simplify this so that we know what it looks like in the simplest form. So we have 2y plus 4 equal x minus 6, which simplifies to be 2y minus x is equal to negative 10. And here we have left the equation in the general form, which is 2y minus x is equal to negative 10. let us look at more questions which will further cement the concepts of coordinate geometry. Now, this is a very good question that I want you to try it for yourself. Find the points of intersection P and Q of the line y equal 2x minus 3 and the curve y equal x squared minus 2x minus 8. How do you go about finding the points of intersection? While I think about that, I will be displaying the other question, which is find an equation of the perpendicular bisector of the line segment PQ in the form AX plus BY plus C equals 0. And the third question that we will display is find the points of intersection R and S of this perpendicular bisector with the curve. Go ahead, solve this question, make an attempt, apply your knowledge. That is the only way you will know if you are understanding the concepts thus far. When you return, we will go through the solution of this question. Now, in order for us to solve this equation, we will equate both equations. So the first equation is y is equal to 2x minus 3. And the second equation for the curve is y is equal to x squared minus 2x minus 8. How do you go about finding this? Right. So since both of them are written in terms of y, you can equate both equations, and you can either use the method of factorization, you can also use the method of the formula, which is the quadratic formula, or you can use the method of completing the square to find the solutions. After you have done that, you will compare your answer to what we have. So I will allow you to pause the video here, go ahead and solve this question. When you are finished, compare your answer to what we have here, which is P, -1, -5, and Q, 5, 7. Now, it did not say which one we should use as P or Q. Therefore, you can use anyone as P or as Q. Therefore, we choose any point to represent P and Q. Now, what is next? Our second question was to find an equation of the point of the perpendicular bisector of the line segment PQ in the form AX plus BY plus C equals 0. How do you go about finding an equation of the perpendicular bisector of the line? Let us go through the solution. Or you can pause the video, go ahead in front of us, and then you return to go through the solution with us. So we first find the gradient. And the gradient is found by using your vertical change written as a fraction to your horizontal change. Therefore, we end up with 7 plus 5 over 5 plus 1. After simplifying, we get a result of 2. Therefore, the gradient of PQ is 2. But let us go back to our question. It said to find an equation of the perpendicular bisector of the line segment PQ. Therefore, if the gradient of PQ is 2, it means that the gradient of the perpendicular bisector of PQ is negative 1/2. You are so much correct. Since we have found the gradient of the perpendicular bisector is negative 1/2, what next do we need to do? Are we finished here? Remember, it had asked us for the equation. Since we know that it is a bisector, it means then that we should go ahead and find the midpoint of the line PQ. How do you go about finding the midpoint of a line segment? All right, so since you have gone through that, let us now find the midpoint. And the midpoint is 2, 1. Remember, go ahead, try for yourself, and ensure that your result is 2, 1. Since we now have the midpoint and also the gradient, we can now go about by finding the equation of this perpendicular bisector. You can now utilize the concept of the gradient point form to find the equation of the perpendicular bisector, which is y minus 1 is equal to negative 1/2 into x minus 2. Remember, I would like you to go ahead, simplify this equation so that it will resemble what we have here. And further simplifying this equation, you should get the equation in the form x plus 2y minus 4 is equal to 0. Remember that your question was to write your equation in this form. And since it had asked to be written in this form, then only this form is accepted or will be acceptable at this point. Let us take a visual look at what our graphs are. So here we have the two lines. We have the line represented by PQ and the perpendicular bisector RS. And as you can see here, it may not look like they are perpendicular, but it looks this way because of the scales that are used. There are two different scales used on both axes. So that is why they are looking like this. But indeed, they are perpendicular, and to prove that they are perpendicular, remember that the product of their gradients should be equal to negative 1. Let us now go ahead and find the solution for C. The question C was to find the points of intersection R and S of the perpendicular bisector with the curve. So we will now find the points of intersection. How do we go about finding the points of intersection? Very good. So the first thing we do is to solve our equations. Since our two equations are x plus 2y minus 4 equals 0, and the second equation for the curve was y is equal to x squared minus 2x minus 8. And as said before, you can use the concept of factorization, or you can use the concept of the quadratic formula, and you can even go ahead now and use the concept of completing the square. Anyone you are more comfortable with, go ahead and use it. And ensure that at the end you get your points of intersection to be R, negative 2.5, 3.25, and S, 4, 0. Once you have gotten these 2 points, then you would have answered your question. And remember, your question was to find the points of intersection R and S of the perpendicular bisector with the curve. Once you have done that and you understand what it is asking, then you are now ready to move to the other objectives on your syllabus. And this question is very important because it is similar to a past paper question. Until next time, I want to say thank you.